Yes, I think I am audible to you now. Yes, okay, ma. Thank you very much. I'm so sorry for the 10 minutes delay. Why? Because so many years back I have done this one, and I'm trying with the same link from evening onwards. I tried 3 times. That might be the problem, using the same link again and again. Okay, so let me know if the document is visible to you clearly or not. So I think if you will watch this video in the laptop, then it is okay. Otherwise it will be too small based on the mobile width. Baseband digital transmission, I think this is visible to you all. Title is visible to you, right? Okay, Shrina. Thank you very much. Now I am going to start the class. So if you watch this in the laptop, 5 members or 4 members, then it will be helpful to you people. Now I will start the session. Discrete PAM signals. Please ignore the surrounding noise. Discrete PAM signals. So why we require this discrete PAM signals? What is the reason for this? We will see. In the 4th unit last, we have the PCM, DPCM, DM, ADM. They are used to convert an analog signal into digital. After converting an analog signal into digital, which format we need to choose? That is decided by this discrete PAM signals. So how many types of representation we have for the digital data also, even though they are in terms of zeros and ones, but what is the representation we have to represent zeros and ones? And what is meant by inter-symbol interference? This is also very important. I think this is already covered in the previous units also. When the digital data are transmitted through a band-limited channel, dispersion in the channel causes an overlap in time between successive symbols. This form of distortion is known as inter-symbol interference. So this is a serious problem in the quality of the reception. So in this chapter we are going to see how the waveform is going to represent even though we have the digital data. On what basis we are going to draw this one. So these discrete PAM signal formats can also called as line coding techniques. Draw the line coding techniques for the given data means we need to draw all these formats. Sometimes they may ask separately, sometimes they may ask they will give one data and draw all the line coding formats for the given data. We have the 6 basic formats for the digital data representation. So coming to line coding, so what do you mean by line coding? Means it is a encoding scheme. It converts sequence of zeros and ones to a suitable format that can be transmitted over a channel. So even though we have zeros and ones, so which is not suitable for the data to transmit over a channel. So what are the suitable formats we have for the digital data to send through a channel are called as line coding techniques, which are also called as discrete PAM signals, which are also called as digital formats also or discrete formats also. In this basically we have two types, return to zero format return to zero format and non-return to zero format. Basically the line coding techniques are, first 3 techniques are divided into 2 types, return to zero and non-return to zero. So what is meant by return to zero and non-return to zero? So put the side heading discrete PAM signals and then write down this definition. What is the inter-symbol interference? When the digital data are transmitted through a band limited channel, dispersion in the channel causes an overlap in time between successive symbols. This form of distortion known as inter-symbol interference. This can pose a serious problem to the quality of reception if it is left uncontrolled. So take this definition up to here, that is enough. What is the inter-symbol interference? Define inter-symbol interference. When there is a overlap between the successive samples, it is called the inter-symbol interference, or clearly the definition is this one. When the digital data are transmitted through a band channel, dispersion in the channel causes an overlap in time between successive symbols, not in the amplitude, only in the time. Overlap in the time between the successive symbols is called as inter-symbol interference. This is one type of distortion. If the definition is completed, let me know. Write down the definition. Only 36 have joined. So I can see your names also here. In the mobile also I have joined the class. Only 36 members are there. Sleena, have you shared this link to the dissection? We plan to complete in online mode. So introduction of any unit is very important. Without the introduction, we cannot read the unit properly, entire unit. So always introduction is very important. So I think definition is completed. Next, coming to the line coding. So define line coding. Sometimes there may be a chance of asking for 2 marks. Define line coding. So it is an encoding scheme. It converts sequence of zeros and ones to a suitable format that can be transmitted over a channel. So what is meant by line coding means it is an encoding scheme. It converts sequence of zeros and ones to a suitable format that can be transmitted over a channel. It is a encoding scheme. It converts a sequence of zeros and ones to a suitable format that can be transmitted over a channel. Okay, I think I will move to next. If you want any time to note down, let me stop there. Okay. So basically this line coding format is divided into two types, return to zero format and non-return to zero format. If a pulse reaches to zero before the occurrence of next pulse, then it is called as return to zero format. So if a pulse is reaching to zero before the occurrence of the next pulse only, so here return to zero means the pulse will present for only half of the pulse duration. So you know that what is the pulse duration? If we have the pulse duration, if the pulse is present only half of the pulse duration, then we can call it as return to zero format. So basically the line coding techniques are divided into two types, return to zero format and non-return to zero format. Return to zero format, put the side heading return to zero format. If a pulse reaches to zero before the occurrence of the next pulse, then it is called as return to zero format. Then it is called as return to zero format. Then it is called as return to zero format. So what is non-return to zero format means? If a pulse does not reaches to zero before the occurrence of the next pulse, then it is called as non-return to zero. Or otherwise, the same definition we can write in some other way for non-return to zero. If the pulse is present for full duration, then that is called as non-return to zero format. If a pulse is present for full symbol duration, then it is called as non-return to zero. Or if a pulse does not reaches to zero before the occurrence of the next pulse, that is also non-return to zero format. You can write in both the ways. You can write in both the ways. Okay. Now, see here the example for the return to zero and non-return to zero format. Suppose for example, if the pulse duration is, the symbol duration is up to here, so from here to here, this is one symbol duration, this is another symbol duration, this is another symbol duration, this is another symbol duration. Suppose for example for 1 we should have the positive amplitude level, for 0 0 level. If we are assuming like that, then actually the symbol 1 amplitude level, positive amplitude level should present to the total symbol duration, but here we are writing the return to zero format. So here for this return to zero format, only pulse will present half of the symbol duration. Suppose for example if this one is the full symbol duration, then half of the symbol duration means this is the half of the symbol duration. So only half of the symbol duration will present, that is called as return to zero format. Here also only half of the symbol duration, here full symbol duration. So for 0 no representation, that's why here we are getting the only 0 only. For 0 there is no questioning of how to draw the half of the symbol duration for 0. Okay, and for one again half of the symbol duration. So what about non-return to 0? So whenever the pulse is present, then the pulse is present for total symbol duration. 1 from here to here 1 bit, from here to here another bit 1 1, and here this is the 0, and here another 1. If the pulse is present for total symbol duration, then that is called as non-return to zero format. If the pulse is present only half of the symbol duration, that is called as return to zero format. Very important, these two. Please make a note of these two. Return to zero format, non-return to zero format. Completed or write-up is completed, let me know. I will give now 8:22. Up to 8:23 I will give the time to note down. Come on, make it fast. Oh, already it is 8:23. Okay, 8:24. If a pulse reaches to 0 before the occurrence of the next pulse, that is called as return to 0. Non-return to 0 format. If a pulse does not reaches to 0 before the occurrence of the next pulse, then it is called as non-return to 0 format. So return to 0 format, non-return to 0 format. Now what are the example formats for return to 0 and non-return to 0? If this one is a symbol duration, the pulse will present for only half of the symbol duration. If the pulse is present for full symbol duration, then it is called as non-return to 0 format. For 0, 0 level only. Take these two examples, return to 0 and non-return to 0. Take those two examples for return to 0 and non-return to 0. So if it is completed, so many people have joined now. Okay, I am going to repeat this once again. Here we are going to discuss unit 5 discrete in that discrete PAM signals topic. So actually discrete PAM signals, in the last unit we have PCM, DPCM, DM and ADM. With the help of those techniques, they are called as digital modulation techniques. An analog signal is converted into digital. After getting the digital data, to transmit this digital data over a channel, we require some line coding techniques. How the 0 has to be represented and how the 1 has to be represented in different line coding formats according to the application. So discrete PAM signals, how to represent the discrete PAM signals, what are the coding techniques we have? They are called as line coding techniques, or which are also called as discrete PAM signals. Discrete means basically they are having only zeros and ones. In this basically we have the two types, return to 0 type and non-return to 0 type. Return to 0 type, return to 0. So basically the return to 0 is represented RZ and non-return to 0 is represented as NRZ. Return to 0 means the pulse will present for the pulse is reaches to 0 before the occurrence of the next pulse. Non-return to 0 means if a pulse does not reaches to 0 before the occurrence of next pulse, then it is called as non-return to 0. Okay. So now, what are the different types of line coding techniques or discrete PAM signals we have? These are the basic types of discrete PAM signals. Everyone note down all these types. 6 types we have. What are the 6 basic types? What are the different types of line coding or discrete PAM codes? Everyone note down these 6 types. In the Monday class, I will surely check your notebooks. Different types of line coding or discrete PAM codes: unipolar, polar, bipolar, split, Manchester format, polar, quaternary, NRZ format, differential encoding. In this unipolar, we have return to 0, non-return to 0, polar, return to 0, non-return to 0, bipolar, return to 0, non-return to 0. Split Manchester format, we have only one format. Polar quaternary, again it is non-return to 0 format. Differential encoding, so again it is also non-return to 0 format. So these coding techniques are very, very important. Easy and important also. For communication, these techniques are very important. So if it is completed, let me know. Okay, I will switch off the fan. Background noise means fan only, I think so. Now I think it is very clear. My voice is also very clear. Okay, ma, that is fan noise. So if the write-up is completed, put a message in the WhatsApp or in the chat box also. Complete. Okay, ma. Thank you. So these are the different types of line coding techniques. We will see one by one. Unipolar. How to draw the unipolar and what is unipolar. So put the side heading unipolar format. Put the side heading unipolar format. So unipolar format, which is also called as on-off signaling scheme. Put the side heading unipolar format, which is also called as on-off signaling scheme. Put the side heading unipolar format, which is also called as, or which is also known as on-off signaling scheme. So draw the on-off signaling scheme for the given data, or sometimes they may ask draw the unipolar format for the given data. Like that they will ask the questions. Sometimes on-off, sometimes unipolar. So here, why the name is given as unipolar means, uni means basically, very well, single polarity. So here the data means in terms of zeros and ones. For one, generally one, for one, the symbol 1, the positive amplitude level we are going to represent. For 0 and 0 amplitude level. That's why here we are going to have only one polarity, that too positive polarity only, single polarity we have. That's why the name is given as unipolar. And why the name is given as on-off signaling scheme means, for 1 the pulse is representing as on pulse, for 0 there is no pulse. So this format can also called as on-off. 1 is for on, 0 off. That's why this format is also called as on-off signaling scheme. So unipolar format, which is also known as on-off signaling scheme. In this format, in this unipolar format, symbol 1 is represented by transmitting a pulse, whereas symbol 0 is represented by switching off the pulse. Symbol 1 is represented by transmitting a pulse, whereas symbol 0 is represented by switching off the pulse. So symbol 1 is represented by transmitting a pulse, whereas symbol 0 is represented by switching off the pulse. So this is the unipolar format. When the pulse occupies the full duration of a symbol, the unipolar format is said to be, full duration means non-return to 0. When it occupies a fraction of the symbol, generally that duration is set, fraction of the symbol duration, generally that duration we are considering it as half of the pulse duration. It is said to be of the return to 0 type. So symbol 1 is represented by transmitting a pulse, whereas symbol 0 is represented by switching off the pulse. That is called as unipolar format or on-off signaling scheme. So the unipolar format is said to be of the non-return to 0 type when the pulse occupies the full duration of a symbol. And it is said to be return to 0 format when the pulse occupies a fraction of the symbol duration. That fraction we are calling it as half of the symbol duration. Then it is called as return to 0 type. So previously we have seen the example. The same example we can redraw here also for unipolar format. So basic type is unipolar format type. The first technique is the unipolar format. So I am scrolling this down. Okay, I think here now you understood what is unipolar format. Okay, so we will go for the example. See here, the data is given as 0, 1, 1, 0, 1, 0, 0. For this, draw the unipolar format in both the formats, that is unipolar format return to 0, unipolar format non-return to 0. Return to 0 means the pulse will present only half of the symbol duration. If this one is the full pulse duration, dotted lines are there, na, that indicates the full symbol duration. in that symbol duration, if the pulse is present only half, then it is called as return to 0. If the pulse is present for total symbol duration, then it is called as non-return to 0. 0, 0. Here 1 we have, return to 0 means only half of the symbol duration. Here 1 means full, here also 1 means full. 0, 1, 0, 0, 0. This is non-return to 0 type. Whereas in return to 0, unipolar return to 0, 0, and for 1 we have the half of the symbol duration, for again 1 half of the symbol duration, and for 0, 0 duration, 0 amplitude level, for 1 again half of the symbol duration, 0, 0, 0. This is the representation of the unipolar return to 0 and non-return to 0. Unipolar return to 0 and non-return to 0. Okay, take these examples. Just take up to here, unipolar return to 0 and unipolar non-return to 0. Don't take this one. Completed up? Waveforms. Take only unipolar return to 0, unipolar non-return to 0. Up to this, that is enough. I think now there is no background noise, only my voice is visible to you, that's it. Not visible, audible. Only my voice is audible. If the waveforms are completed, let me know. బ్యాక్గ్రౌండ్ నాయిస్ వస్తుంది కదా ఫ్యాన్ స్విచ్ ఆన్ చేస్తే. Yeah, okay, I'm moving to next format. Put the side heading polar format. Put the side heading polar format. Put the side heading polar format. You can zoom the document ma. If it is not visible to you in the mobile, you can zoom it. So మీకు ఎంత జూమ్ కావాలంటే అంత జూమ్ చేసుకోండి, రాసుకోండి. ఎక్కడైనా అర్థం కాకపోతే జూమ్ చేసినా మీకు వస్తుంది. ఎందుకంటే నేను మొబైల్లో కూడా చూస్తున్నాను క్లారిటీ ఉందా లేదా అని చెప్పేసి. సో పోలార్ ఫార్మాట్. నెక్స్ట్ టైప్ is the polar format. Polar format, polarity. So generally polarity means which should have both positive and negative. And here we have the bipolar and here we have the polar. Generally polar means positive as well as negative. So what is the difference between the polar and bipolar? We will see in the next. Polar format. In the polar format, a positive pulse is transmitted for symbol 1 and negative pulse is transmitted for symbol 0. Both we should have positive as well as negative. Whereas in the unipolar format, we have only positive pulse for the symbol 1 and there is no pulse for the symbol 0. Polarity, we should have both positive as well as negative. That's why this format is given the name as polar format. In the polar format, a positive pulse is transmitted for symbol 1 and a negative pulse for symbol 0. It can be of non-return to 0 or return to 0 type, which is shown in the below figure. You can take it as below figure. So here in the polar format, a positive pulse is transmitted for symbol 0 and a negative pulse is transmitted for a positive pulse is transmitted for symbol 1 and a negative pulse is transmitted for symbol 0. This polar format is divided into return to 0 type or non-return to 0 type. Okay. So we will see the example. Unlike the unipolar waveform, a polar waveform has no DC component. In the unipolar format, we have the DC component, that is 0 we have, provided that the zeros and ones in the input data occur in equal proportions. And here in this, we have the zeros and ones in the equal proportions, positive as well as negative. So polar format, a positive pulse is transmitted for symbol 1 and negative pulse is transmitted for symbol 0. And it is also divided into two types, return to 0 and non-return to 0 type. So now we will go for the example of polar. This one is the example and the data is same data. We are getting 0, 1, 1, 0, 1, 0, 0, 0. That is the data. Take the data. Write on the data. 0, 1, 1, 0, 1, 0, 0, 0. So minimum 8 bits we need to represent for any example. Okay. So the data is given as 0, 1, 1, 0, 1, 0, 0. And what is the representation of polar return to 0 and polar non-return to 0? Take these two waveforms. So for 0, we should have the negative pulse. For 1, we should have the positive pulse. And return to 0 means only half of the symbol duration. Non-return to 0 means full symbol duration. If the waveforms are completed, let me know. Okay, ma. Thank you. So now this is the second format. Third format is bipolar format. So put the side heading bipolar format. Put the side heading bipolar format. Third format is the bipolar format. So this bipolar format is also called as pseudo ternary logic. Pseudo, pseudo, T-E-R-N-A-R-Y, pseudo ternary logic or pseudo ternary signaling scheme. So bipolar format, this is the general format, general name, and pseudo ternary is very important. They will sometimes they will ask, mostly they will ask, draw the pseudo ternary logic for the given data. So you may forget sometimes. Why? Because we will stress only on bipolar format. So try to remember this one, pseudo ternary logic, which is bipolar format. So put the side heading bipolar format, which is also known as pseudo ternary logic or pseudo ternary signaling scheme. Pseudo-ternary, pseudo ternary logic, which is also called as AMI format. Which is also called as AMI format. It is also called as AMI format. AMI, capital A, capital M, capital I. Alternate mark inversion. Bipolar format is also called as pseudo ternary logic, which is also called as AMI. Alternate mark inversion, which is also called as alternate mark inversion. Which is also called as alternate mark inversion. These are the different names of the bipolar format. So now first we have seen the unipolar format, single polarity, polar format, we have the two polarities. Bipolar, bi means generally two. So why this format is given the name as bipolar means for the single symbol 1 we have the two polarities. Symbol 1 we have two polarities in this format. What are the two polarities? Positive as well as negative. For symbol 1 we have the two polarities in this, that's why the name is given as bipolar format. Why the name is given as pseudo ternary? Pseudo means generally duplicate. What is the meaning of the pseudo means? Duplicate. Here why the name is given as duplicate ternary logic means for symbol 1 we have both positive as well as negative level. When the first occurrence of the symbol 1 is positive and the next occurrence of the symbol 1 is negative. If the first occurrence of the symbol 1 is negative, then the next occurrence of the symbol 1 is positive. So the occurrence of the first symbol 1 that may be either positive or negative, we don't know. But the successive symbol 1s are going to change the amplitude levels from positive to negative and negative to positive. So that's why we are calling this one as pseudo ternary. Ternary means basically 3. Here for symbol 1 we have the positive level and negative level. Symbol 0 we have the 0 level. 3 levels we have positive, negative, 3. So that's why the bipolar format is also called as pseudo ternary signaling scheme. And the next another name for the bipolar logic is, can anyone put in the chat box? What is another name for the bipolar format? Just now I told what is another name for the bipolar format other than pseudo ternary logic? Shortcut also you can type. Just now I told. Very good. AMI format, alternate mark inversion. Alternate mark inversion. Pseudo ternary logic, or which is also called as alternate mark inversion. Yes, alternate mark inversion. Very good. So everyone is listening. I am so happy. At least one answer I expected, but I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very happy. Okay, next. So what is here in the bipolar format? Positive and negative pulses are used alternatively for the transmission of ones, with the alternation taking place at every occurrence of a 1. So here and 1 you can write, and no pulses for the transmission of 0. Here what is meant by bipolar format means whenever we have the symbol 1 there, thus for the symbol 1 the levels are changing from positive and negative pulses are used alternatively for the transmission of ones. Suppose for example if the first one is having the positive pulse, then the next one whenever it comes, so suppose for example 1 0 1, for the first one it's the positive level and the next one 0 0 level, for the next one it should be the negative level. So that's why it is also called as alternate mark inversion. Inversion taking place for each and every mark, that is symbol 1. Okay. So positive and negative pulses are used alternatively for the transmission of ones in brackets with the alternation taking place at every occurrence of and 1, and no pulses for the transmission of zeros. It can be of the non-return to 0 type or return to 0 type. In this representation there are 3 levels: plus 1, 0 and minus 1. That's why hence the name is given as pseudo ternary. Hence the name is given as pseudo ternary. Hence the name is given as pseudo ternary logic. Bipolar format is also called as alternate mark inversion, which is also called as pseudo ternary logic. They mostly ask what draw the pseudo ternary format or AMI format for the given data. Mostly they will ask like this only, not the direct question, that is bipolar format. Okay. So shall I move to the next? That is a waveforms for this bipolar format. Okay. So example, take the data 0 1 1 0 1 0. 0 1 1 0 1 0. You can take any data, no need to take same data. Okay, you can take any data in terms of zeros and ones. So bipolar return to 0 whenever if the first one is positive, then the next successive one should be negative. And here we have the 0 for 0 0 level, and the next one here it comes, then the positive level. Previously it is negative, then it is positive. This is for return to 0 format. Coming to the non-return to 0, for one full symbol duration, for the next one full symbol duration, that to negative, for the next one full symbol duration, that to positive. Alternately the amplitude level is changing for the symbol 1 from positive to negative and negative to positive. So this is the pseudo ternary logic or alternate mark inversion, which is bipolar format. Take this example. Okay. So today I think 20 minutes time is wasted. In the next class, maybe tomorrow I will take from 9 to 10. Is that okay for you people? Timing 9 to 10. Tomorrow is Saturday now. So I have so much work. That's why I will take the class from 9 to 10. Is that time is okay for you people? 9 to 10. Okay, ma. Tomorrow I will take 9 to 10 class. But tomorrow is Saturday, na? That's why. I have work at home to finish. Yeah, okay ma. Completed waveforms, example waveforms. So if the waveforms are completed, let me know. Ma, if some people are not able to join 9 to 10 class, I will share this video after the class. You try to listen and try to complete the notes according to that. Okay, that is also flexible in this YouTube. That's why I tried to do the online classes using YouTube only. That will be helpful in the future also. Yeah, okay ma, thank you very much, Venkateswarlu. Now we will move to the next one, that is the split Manchester format. Put the side heading split Manchester format. From here onwards we will see in the next class. Split Manchester format. Put the side heading SPLIT, split Manchester format, which is also called as biphase baseband signaling scheme. Put the side heading as split Manchester format, which is also called as biphase baseband signaling scheme. Split Manchester format, which is also called as biphase baseband signaling scheme. Put the side heading split Manchester format, or which is also called as biphase baseband signaling scheme. So I am going to end this session here only. Thank you so much for attending the class. Tomorrow I will take 9 to 10 class. I think that is the convenient time for you people, for me especially. Why? Because tomorrow is the Saturday weekend. That's why after 9 only it is possible for me to take the class. Okay. So thank you very much for attending. I am going to end this session. You can exit or you can close the session. We will continue the tomorrow from here onwards, split Manchester format. I will share this link after the class. If anyone is absent or not able to get the class properly, they can listen after the class also. Try to complete the notes for the next class, that is for Monday class.